This modern greenhouse is designed for efficient and sustainable plant cultivation, integrating advanced technology with natural resources. The structure features transparent walls and a slanted roof made of glass, allowing sunlight to enter and creating a warm environment ideal for plant growth. Inside, plants are neatly arranged in rows within soil beds, optimizing space and simplifying maintenance. The greenhouse is equipped with an automated irrigation system that uses a water tank and pipe network to ensure even and efficient hydration for plants. Additionally, it is fitted with a water level sensor, soil moisture sensor, and temperature sensor, allowing for real-time monitoring and control of key environmental factors. Additionally, the greenhouse features a fail-safe system designed to prevent flooding. If the water level rises beyond a safe limit, excess water is automatically redirected through a drainage pipe, protecting the plants and maintaining optimal soil conditions. The slanted roof also aids in rainwater drainage, and the ventilation system ensures proper air circulation to prevent mold growth. This greenhouse provides a sustainable, user-friendly, and technologically advanced solution for growing vegetables. Before we get into our coding, there are two things that we need to define, which is liquid crystal I2C and also server library. For liquid crystal I2C, it is purpose to facilitate communication with an LCD display using the I2C protocol. For the servo library is used to manage the precise angular movement of the servo motor. And now, we get into the pin assignments part. First of all, we already said the temperature pin is on A0, which is read the data from the temperature sensor. This pin receives analog voltage values corresponding to the temperatures. After that, we already set humid pin at A1 to read data from the humidity sensor, which also provides analog voltage levels. So next, we have output pins, which is vent motor pin, water pump, red pin, yellow pin, green pin for LED, buzzer pin, and sewage servo. And then we have trade pin and echo pin, which is sense and ultrasonic pulse to trade pin, and echo pin for receive the reflected signal to calculate the distance to the water surface. Next, we initialize the LCD with the I2C address, which is 0 times 26. And then we assign constant threshold for each output component. And then we need to assign variables for ultrasonic distance sensor and also create an object name, which is sewage servo of the servo class. And then we already set up our Y setup, which is to prepare sensors, actuators and peripherals for operation, ensuring the system starts in a safe and predictable state and enabling communication and debugging during development. And finally, this part of coding is to attach servo and set the initial position in the switch when the switch closes. And then initialize serial monitor, initialize the LCD and turns on the backlight of the LCD.
Assalamualaikum and good afternoon. My name is Muhammad Hafizudin Ali, and I'm going to explain my part of the coding and the assignment about the temperature control. So there's this line about the temperature. By the way, we have declared about the maximum temperature, maximum, low and minimum temperature threshold. So we have declared here, this is the threshold. So this section of the code will control the ventilation motor or DC motor in the system. So the speed of the vent motor will adjust accordingly according to the temperature and humidity readings. So generally the goal is to maintain an ideal environment or temperature for the plants. So let me explain about the coding. So the coding is right here. So let's say if the temperature is above the maximum temperature threshold, then the Arduino will send a signal to the motor pin, which will activate the DC motor and run at the highest speed 255. And then if the temperature is above the low temperature threshold, which is it's not that high or not too low, then it will run at a moderate speed 166. And also when the temperature is above the minimum temperature threshold, then the DC motor will not run until it has achieved a desired temperature. So let me try to simulate it. So as you can see here, let's say if the temperature is too high, then the motor will run. This is the motor, this is the DC motor. But let's say if the temperature is above the minimum temperature threshold, so it will not run at all. This is the minimum temperature threshold, and the motor is not running. I think that's all from me. Thank you.
I will be explaining more on soil moisture sensor. A soil moisture sensor is a sensor that controls the soil moisture level. Other than that, it also controls the LED to act as indicator and controlling water pump to keep on providing the soil a perfect moisture level. Let's see the coding. Here are the providing coding. As you can see here, our first condition, if the humidity is lower than humid low threshold, the water pump will be activated at 255 speed. Then the red LED will be turned on to show that our soil is at dry level. For our second condition, if the humidity is more than our humid low threshold, but then it is lower than the humid high threshold, the water pump will still be activated, but the speed will be decreased to 128. The red LED will be turned off, changing to yellow LED. The yellow LED shows that our soil is at humid level. Then for our last condition, which is our humidity is more than humid high threshold, the water pump will be turned off. Then the yellow LED will be turned off, change to green LED, showing that our soil is at submerged level. To get a clearer view, let's start the simulation. At the beginning of the simulation, the red LED is already turned on, then the water pump is already turned on at a higher speed. We can see the humidity level at the soil moisture sensor. As shown here, the humidity is 0. We can increase the humidity by changing the soil moisture sensor. As we increase the humidity, the red LED will be turned off, changing to yellow LED, showing that our soil is at humid level. Then the water pump will be slower. But if we increase the humidity to the maximum level, the yellow LED will be turned off, replaced with green LED, showing that our soil is at submerged level, then stop or turn off our water pump. Even if we reverse this process, we will gain the same output. And that's all for the soil sensor.
In this section, I will explain the fail-safe operation of our project greenhouse system project. Our fail-safe operation use an ultrasonic distance sensor to detect flood. So let's take a look at the coding. So in the first condition, if water level is less than water level threshold, this line checks if the water level is below the defined threshold, which is 100. If this condition is true, then the next line will be executed. So the next line, analog write water pump pin 0 turns off the water pump by sending 0 signal. Then on the LCD screen, greenhouse is displayed on row 0 at column 1 and flooding is displayed on row 1 column 2. The indicating this line of code. Next, the warning system and the control output will be activated. So in the next line, digital write buzzer pin high. This turns on buzzer on high to alert about the low water level, and the line sewage servo.write 90 sets the servo motor to 90 degree, simulating an open sewage system. Now moving on to the next condition, else, which is water level more than water level threshold. This condition will execute a different set of instructions. First, digital write buzzer pin low turns off the buzzer, and sewage servo.write 0 closes the sewage system by setting the servo motor to 0 degree. Lastly, on the LCD, simulation is displayed on row 0, column 1, and starting is displayed on row 1, column 2. So in the simulation, the second condition is executed. Where right now the buzzer is turned off, the sewage servo is at 0, and the LCD is printing out simulation starting. And on the first condition, this will turn on the buzzer. The sewage servo is at 90 degree. The LCD is printing out greenhouse flooding, and the water pump is at 0 RPM. This safe operation, it shows that the greenhouse system will have no problem relating to flood. Thank you.